Okay, welcome to the next type of naming, type 2. In type 2 naming, what we're going to worry about is the D area, the lower P, and the F area. So again, we're taking from boron to octium, that diagonal line, and we're going to be below that diagonal line. Now, we're still going to balance the charges, so we're still going to use an algebraic equation to balance the charges. We don't write ones when we balance equations. We're going to name the first element. We're going to use the charge of the first element and list it in parentheses as a Roman numeral. We're still going to, just like type 1, change the ending to IDE if it's an element, and we're going to keep the ending if it's a polyatomic. So let's do an example here at the bottom. Say that I had manganese, Roman numeral 3, hydroxide. Now, the Roman numeral 3 tells me the charge on the manganese. So manganese has a +3 charge. Hydroxide's one of our polyatomics. We look on the back of our periodic table and find that it is OH minus. Now remember, we've got a +3 and a -1 that have to add to equal 0. So I need to make that statement true. So I times the +3 by 1, and then I times the -3 by 3. Those become our subscripts. So as I'm writing, I would write MN. I need one of those, but I don't put the subscript as 1. And I need 3 of the OH group. Since it's a group, it goes in parentheses, and we put the 3 on the outside. Alright, let's go forward and do a couple of examples here. So, we take the board and divide it into 4, so we're going to do 4 different examples. Up here in the left-hand corner, let's take a moon. So let's take, say we're getting vanadium, Roman numeral 5, oxide. Okay, so vanadium, we know the charge because of the Roman numeral. So vanadium has a +5 oxidation state. And oxygen has a -2. Now remember, we have 5 plus a -2, and this has to equal 0. So we have to times it by something. The common factor between 5 and 2 is 10. So to get the vanadium to be a 10, we times it by 2. And to get the oxygen's charge to be 10, we times it by 5. Those become our subscripts. So vanadium has a subscript of 2, and oxygen has a subscript of 5. Now it's just a reminder that a lot of you don't know your Roman numerals. So let's take a minute and go through the Roman numerals. I is 1, double I is 2, triple I of course is 3, 1 with a V, that's 4, a V is 5, a V with a 1 is 6, a V with 2 1s is 7, a V with 3 1s is 8, a 1 and an X is 9, and an X is 10. So I'll do that up here through Roman numerals. Let's take another one. This time we are going to go backwards. We are going to have the formula, but we've got to name it. So let's take the formula Cu2O. We know oxygen is a -2 because it's 2 away from being a noble gas. Copper is down in the D, the F with a long P. We have 2 of them, but we don't know what charge it's taking right now. This equation has to add to equal 0. But to make this statement true, we solve the equation 2x equals 2, x equals 1. So the copper charge is a +1. We now go and write the name by saying copper. Put the Roman numeral in parentheses, which is 1. And then name the last element, which is oxygen, since it's an element, change the element to IDE. And it's copper monoxide. Let's take another one. Say that we had Mn2O5. Now again, Mn is in the DB after the lower P, so it's going to be our X, and we have 2 of them. So we're going to go 2X plus, we have 5 oxygens, and oxygen is 2 away from being a noble gas, so it's a -2 charge. Overall, we have a charge of 0 for the whole equation. So simplifying this down, we get 2x minus 10 equals 0, 2x equals 10, and x equals a +5. And I realize a lot of you can do that in your head and figure it out real quickly. You don't have to solve it all the way down. If you know that x is 5 just by looking at the equation right here, that's great. Okay, that tells us the charge on manganese is 5. So we would write manganese with a Roman numeral 5 in parentheses, and then the N again is oxygen, changing the N to IDE. Let's do a few more just so you got this down. Again, I'm going to take the 4 and divide it into 4 so you get 4 of them up at the same time so that you can look and see what's going on. Alright, let's do 10 with 4 chlorines. So, again, we set up our equation. We have 1x, because there's only one 10, plus we have 4 chlorines. Chlorine's 1 away from being a noble gas, so it's going to be -1, and that has to equal 0. So x here is going to equal 4. So we would write 10, Roman numeral 4, and then chlorine, we change the ending to IDE. Let's do a third one here. Let's take W and have it be a 3, and P of 4, and have it be a 2. Okay. Alright, so here we have tungsten, and we have 3 tungstens, but we don't know the charge on tungsten, so it's going to be our X. So 3X plus 2 times a group PO4. Now you look on the back of your periodic table, find PO4, and it happens to be under the -3 column. That has to equal 0. So I've got 3x minus 6 equals 0. And if we solve that down, x is going to equal a +2. So we would write for the final name, tungsten, Roman numeral 2, and then phosphate. Okay, let's try a couple more going backwards again. I'm going to give you the name and see if you can write the formula. Let's do titanium, sulfate. Okay, so remember that the Roman numeral 3 gives me the charge on the titanium. Titanium has a +3 charge. Sulfate is something we can get from the back of our periodic table, which is SO4, and it's a -2 charge. So you got to think again, what times 3 plus what times -2 is going to equal 0? Well, the common factor between 3 and 2 is 6. So if I times this one by 2, I'll get a plus 6. And if I times this one by 3, I'll get a negative 6. Plus 6 minus 6 equals 0. So I write T I subscript 2, because I need 2 titaniums to go with, since I need more than one of the sulfate, I put it in parentheses, SO4 and 3. All right, one more time, and then we'll go to the worksheet. Let's do iron, phosphate. Okay, again, the 2 tells me the charge on the iron. So here we go. We've got a plus 2 on iron. And if we look on the back of the periodic table again, PO4 is a minus 3 charge. So we've got plus 2 plus a minus 3 has to equal 0. So we're going to have to times these by a number. And again, the common factor is 6. So if I make this a 3 and I make that a 2, that statement is true. So I got FE subscript 3, parentheses, because I need more than one of the PO4, PO4 subscript 2. Now, why are you making a mistake of putting parentheses if you need only one of the group? Don't do that. All right, we're going to go back and look at your worksheet, which is right here. Here's some examples. You're going to need to write in positive ion. So let's look at this. We've got magnesium 5. Remember, the 5 tells me the charge on the manganese. So over here on the left, I'm going to need positive ion. I'm going to write Mn plus, whoops, sorry about that. Mn plus 5. Alright, I'm going to change pens here so we need to get a thinner line. And put my fingers in. Okay. Chloride is my negative ion. It's a Cl with a minus 1 charge. Well, common factor here is 5, so we're going to need 5 chlorines to add to 1 manganese. Because remember, plus 5 plus minus 1 has to equal 0. So how many of these are we going to need? How many of these? 1 and 5. So I'm going to write Mn Cl 5. Alright, let's go to the next one. The next one we're going to do is giving us a chemical formula, so we've got to go backwards a little bit. So, we've got 3 vanadiums. I'm going to write this down, give an erase it. 3 vanadiums we don't know the charge of, plus 5 PO4 groups. If you remember, look on the back of your periodic table, it's a minus 3, and it's also called a phosphate. So I can put phosphate up here right now, because I know it's going to end in phosphate. Now, if I solve this down, 3x minus 15 equals 0. 3x equals 15, x equals plus 5. So my charge on vanadium over here is plus 5. Phosphate, that group PO4, was a minus 3 charge. I'm going to go ahead and erase that. So we keep working down below. Now, to finish the medium, I need to put vanadium with a Roman numeral 5 in parentheses. Next we have copper 1, again related. The 1 tells me the charge on copper, so I know I need to put it over here, Cu plus 1. And you can put a plus here, plus 1, it's fine. Sulfide is sulfur, and it is 2 away from the noble gas. So it's going to be a negative 2 charge. So we've got a plus 1 and a negative 2, so we're going to need 2 coppers to go with 1 sulfur. Let's take another one. We're going to take lead, and it's a positive 2, so I've already write over here on the right, name lead, Roman numeral 2, and it's with an NO3. NO3 on the back of your periodic table is a nitrate. So ready to get the name without having done it. I've got plus 2, minus 1. I need 2 of the minus 1 to add to the plus 2. So PB, parentheses NO3, parentheses 2, and we're done. Now the same thing's going to happen with the bottom one. We've got chromium, and it has a plus 3 charge. So chromium, Roman numeral 3, and SO3 on the back of your periodic table is sulfite, ITE, because it's lost one oxygen from sulfate. Plus 3 and a minus 2, common factor is 6. So to get 6 for chromium, I'm going to need 2 of them. To get 6 for the sulfite, I'm going to have more than 1, so it's going to go in parentheses. And I'm going to need 3. Alright, so here's some examples. This part right here, down in this area, is your turn. Make sure that you write all the charges. A lot of them are losing points because they're not writing charges of the ions, the negative and the positive. This will be out of 80, so it's a half a point box. If you need any help, let's come on in and ask me some questions. Thanks.